Okay, question 9. This one's not so bad. So we need to integrate between 0 and 1 this thing, which we've got. Now, they're kind of playing about with you with this because really root x is just x to the half. And putting it on the outside of the bracket, I'm just going to get x to the half times 1 take x. So x to the half times 1 is just x to the half, take away, and this has kind of got an invisible 1 on it. We add the powers, so we get x to the 3 on 2. This is going to be much easier to integrate than what we had there previously. So we get x to the 3 on 2 dx. So when we integrate this thing, well, we can just add 1 to the power, divide by the new power. So we're going to get 2/3 x to the 3 on 2. Take, add 1 to the power, 5 on 2. 2/5 x to 5 on 2. And we're doing this between 0 and 1. So when we substitute in the 1 and the 0, we're going to get this first bracket, which is 2/3 of 1 to the power of 3 on 2, which isn't going to do very much at all. Take 2/5 of 1 to the power of 5 on 2, which again isn't going to do much at all. Take away 2/3 of 0, power of 3 on 2. Take 2/5 of 0 to the power of 5 on 2. So this whole thing's going to come out as 0. Over here we've just got 2/3, take 2/5, which isn't the nicest fraction to work with, but it's nothing too scary. So we're going to get times by on the top and bottom by 5 over here. So we're going to get 10/15, take away 6/15. So I'm going to get 4/15. So that's my area. In a test like this, really, you could put units squared, just because they've not given us any real measurements for this, just to ensure that you're getting those 2 marks. The gradient of the tangent to the graph is a very weird way of saying differentiate, because that's all that this is after. So it's asking us to differentiate the graph of f, and it's already told us that the answer is this. It's told us that. This is a show that question. So this always means that it's told us the answer already. So really all we've got to do is show this and make sure that we don't make any mistakes. So I'm going to look at our thing. So f of x is the square root of x multiplied by 1 take x. So we'll write this out, just to let the examiner know we know what we're doing, and we're looking for f dash of x. We can see the format they want it in here. We know that it's going to come out as this kind of neat fraction, so I'm still just going to multiply it out because I don't want it any other way. So I'm going to get x to the 3 on 2. So I'm going to multiply by the power. So this is still f of x technically. So now I'm going to be doing my differentiation step, multiplying by the power, knocking 1 off the power. Once again, multiplying by the power, which is going to give me 3 on 2, x to the half. Now I can convert things back. So I'm going to get a half of, really this is the square root of negative x, so this is going to go down here. Alright, I'm going to leave that there for now and just play with it in just a moment. So this is going to become 3/2 multiplied by root x. So I'm starting to get close to what they've got. I can start to see this 3 and things falling into place. I want to create a common denominator for both. So this one on the right, I'm essentially going to multiply sort of top and bottom by root x. So this is going to allow me on this right hand side. So I've got take away 3 root x times by root x over 2 times root x. I'm just creating this common denominator, and this 2 on the bottom of that half is just going to get pushed to the bottom of the fraction, so I've got 1/2 root x here. So I've now got my common denominator. my root x times my root x here is just going to give me x. So I'll get 1 take 3x all over 2 root x. And there's my mark. So part C is not too bad considering it draws on what we've done previously. Actually, it tells us that we have a 45-degree angle, which makes things nice and easy because this tells us that the gradient of this line segment is going to be 1. And considering that we can see that this will be 45 degrees because this will be the same, we actually get a gradient of -1 here. So what we're going to concern ourselves with is just this tangent point. We can see that it touches and we're told that it touches. So what we're going to do is we're going to say, okay, well if the gradient is 1 take 3x over 2 root x, we know that the gradient at this point must be -1. So we're going to let that equal -1. Then we're going to work this through. This is going to give us the x coordinate at this particular spot. So when we work this through, we're going to get 1 take 3x is equal to -2 root x. I'm going to bring everything over to one side. So I'll get 3 take 2 root x, take 1. At this point, I'm just going to say let a equal root x. This will just make my life a little bit easier because if you think about it, a squared therefore is root x times by root x, which is x. So what I actually have is 3a squared, take 2a, take 1. Factorizing this shouldn't be too difficult. So I'll know that I've got a 3a and an a. I'll know that I've got a 1 and a 1. And I've just got to think, okay, well I'm taking away the 3 and plussing the 1. However you want to do that, it should be something that's in your head. So what you'll get is either a is equal to 1 or a is equal to -1/3. Now, considering that our a is actually root x, we can actually reject this negative answer because we can't get a negative root. So we get root x equals 1, which implies that x is equal to 1. Now this isn't the end. We need to go back and have a look. We said that that was going to be the x coordinate. So considering that this point is shared by our f of x line and our new line BC, we can say actually this point, this x value that we've got of 1, we can substitute this into our f of x. So our f of x was square root of x, 1 take x. So substituting that in, f of x at 1 is square root of 1, 1 take x. Alright, so 1 take 1. We can actually see that this is 1 times by 0. So this is actually 0. So our diagram's actually a little bit off. The point of intersection is actually right there. It has a tangent right on 0. So actually the point that we get here is 1, 0. Now considering this goes up at a 45-degree angle, we can actually now work out that this thing is going to actually intercept here at 1, which gives us our y-intercept. So when we're talking about getting it in the form of y equals mx plus c, which is what the question's asked for, our m being our gradient is 1, and our c, our -1, and our c being our y-intercept is 1. So my final answer for this is actually y is equal to -x plus 1. Now, part D is much the same in a lot of ways, but it's given away 4 marks for this. So if we have a look back up here, we've got this line which we know there's a gradient of 1. We've got this line which we now know the equation of, so we're happy with that. And what we're going to do is we're going to work out the equation of line AC. Then we're going to say, where does this intercept with the line BC, which we already have? So we need to work out AC first. So AC, the line, we're going to work this out using the same technique as above. So 1 take 3x over 2 root x is equal to 1 this time because our gradient is 1. So multiplying both sides by 2 root x, 1 take 3x is equal to 2 root x. Gathering all my items on one side, I'll get this. Much the same tricks as before. I'm going to let a equal root x. I'm going to get 0 is equal to 3a squared plus 2a. Take 1. So I'm going to get 3a, a, 1, 1. This time though, it's going to be the other way around. This is going to be the negative, this is going to be the positive. And this is going to tell me that either a is equal to 1/3 or a is equal to -1. Considering that this is root x, this one can't happen. So what we get is x is equal to 1/9. Going to do the same thing again. We're going to do f of 1/9 now to figure out what that point actually is. So we've got the square root of x times by 1 take x. Square root of 1/9 is 1/3. We've got 1 take 1/9, which is 8/9. So we're going to get 8 on 27. So we know that there is a point on this line, which is 1/9, 8/27. Now that we know that, we can use that information because what we're after is y equals mx plus c. We know that m is 1, so we now get y equals x plus c, and when we substitute in these coordinates, our x value being 1/9, our y value being 8 on 27, we can find our c value. So 8 on 27th and 1/9, I'm just going to change this to being 3 on 27, just to make my life easier. We'll get this to the other side, 5 on 27 is equal to c now. So we have the equation for AC. So AC, the equation for that line is y is equal to 1x, so just x, plus 5 on 27. So we want to find out where this line, AC, and where our previous line cross. So we want to find where x plus 5 on 27 crosses over with the line -x plus 1. So x plus 5 on 27. So I'm going to bring the x's over to one side. I'm going to move that 5 on 27 to the other side, so I'll get 22 on 27. So x is equal to 11 on 27. Now I'm going to substitute this into, I'm going to choose my easier one, so I'm actually going to substitute this into this line here. So this is actually getting subbed into -x plus 1, so I'll get y is equal to -11 on 27 plus 1, which means y is equal to 16 on 27, which means that my point C is equal to 11 on 27, 16 on 27. And I'm done. That's the end of the paper.